Welcome to Spring LIB.
Okay, so in this question we have a few different substrates and reactions, the first of which is this secondary alcohol reacting with sulfuric acid and heat, which tells us we're looking at an elimination reaction. Okay, and given that it's an acidic elimination reaction like this, we should expect to get the most stable alkene out as our product, right? Which means we should get the double bond in the middle of our carbon chain, and we should get the trans product out. Okay, next we have this cyclopentene with a chlorine and a methyl group. Okay, and I draw my L's as cursives in chemistry, so that's Cl for chlorine, so as to not allow L's and I's to get mixed up. And this is reacting effectively with potassium T-butoxide, right? Or what really matters here, we've also got HMPA, but potassium, the T-butoxide is the part that matters. This is a strong, bulky base, right, which tells us that we're going to get an E2 reaction for one, but also important here is the fact that we could form a double bond here, or we could form a double bond there, and this bulky base tells us that we're going to get the Hofmann product, or the less substituted alkene, or we're going to form an alkene with one of we're going to abstract one of those protons. So our final product then would be this alkene right here. Okay, next we've got cyclohexane with a ethyl group on a wedge here and a dash to bromine here. And our reagent is this sodium thioether, or sodium plus S minus CH3. Recall that sulfur is basically not basic at all, but it is very nucleophilic, especially if we're talking about negatively charged sulfur. So this is a very strong nucleophile, right? Secondary substrate, strong nucleophile, not basic at all. We're looking at an SN2 reaction, right? So it's going to displace bromine via backside attack. And where we previously had bromine, a dashed bromine will have a wedge to our, what is now like a thioether. So a wedge to SCH3 and ET, ethyl, on the left. Okay, and finally, we have a cyclopentane. Right, we've got a CH3 up here. Okay, and we've a tosylate, right? Remember, OTS is a very good leaving group. So we've got a good leaving group, and we've got sodium ethoxide in ethanol with heat, right? So the fact that we're in ethanol and using heat tells us it's more likely this is going to be an elimination reaction, right? We're using ethoxide. Ethoxide could be either SN2 or E2, but in terms of putting it in a polar product solvent and adding heat, that strongly favors elimination. So an elimination reaction. And ethoxide is a somewhat nimble or small base, which means we're going to get likely the Zaitsev product. And in fact, this hydrogen is on the carbon which would allow us to form the Zaitsev product there, is properly oriented. It is anti to the tosylate, so we can and will form a double bond on that side of the molecule. So our product then should be that.